Okay, in this video we'll talk about push button switches. And here I have a push button actuator. Got a green contact block which is normally open. I know that because you can see the symbol there between 3 and 4. It's an open symbol. And if I look at the bottom, when I push it, see the black pin that comes up? But green is sort of the universal color for open contact. Okay, this has one contact block. I can put another one right here, and I can stack them if I want to as well. Okay, so let's look at another push button actuator. This is a start-stop push button. Got a stop and a start motor control function built into it. It's got an open and a close contact. Start moves to open, stop moves to closed. Okay, so it's like 2 in 1. So I don't need just drill one hole and put one switch instead of 2 switches. So it saves some space and it saves money as well. And it keeps everything in one spot. Start, stop, start, stop. So let's look at the diagram that goes along with this type of switch. Okay. So this is a push button actuator. So push button 1, that's like this switch, this push button 1 here. It's normally open. If I push it, control relay 1 turns on. Okay, I did not number the terminals on this. I don't have a control relay in front of me, so I don't know what the terminal numbers will be. It'll depend on the relay. On the push button switch, I think it was 3 and 4, so I could put a 3 and a 4. Let me see if I can add that. It would be a 3 with a box and a 4 with a box. Okay, 3, 4. That's all it does. So if I let go of the push button, the relay turns off. That's it. Push button 2 is normally closed. That's a red block. That's a 1, 2 on the terminal numbers, 1 and 2. I press it, control relay 2 turns off. So it's normally closed. Normally current flows through it and energizes the relay. Okay. Well, here's the start-stop push button, the red-green that I just showed you. So stop is usually in front. It doesn't have to be, but it's kind of traditional to put the stop out in the front here. So it comes through on terminal number 1, goes out on number 2, comes into 3 on the start, goes out on 4. Okay. So there's always a lot of confusion, I guess, about how to hook this up. Here's how I do it. It'll save you a lot of time and aggravation. You come off the power positive 24 with a wire, and you terminate it on screw number 1, and you put a little line through that. Like so. And don't think about it again. Okay? So come off of terminal number 2, put a little jumper wire to terminal number 3, label it wire number 4, and mark it off. And forget about it. So come out of terminal number 4. I'm going to go into the motor. This is a motor starter now, not a control relay. So this combination of coil and overload is a motor starter. Okay. So a motor starter coil in series with an overload contact. What that does is if the motor, if it overloads, it will turn off the motor starter so that it prevents it from overheating. Okay. So that's a combination. Those two go together. They're combined in one package. So let's go back to this. So let's say I've connected this wire number 5. The next thing I'll do, on the starter itself, there will be an auxiliary contact, an aux contact. That's an open contact, so when the starter turns on, this contact closes. So when it closes, the current goes through that, goes around the start push button. This is known as a seal-in circuit. Seal-in. It seals in the operation of the starter. So that means that it's got some memory to it. I can let go of the start push button and it continues to operate because the current goes around the push button and keeps the coil energized. Okay, this is a very classic circuit, start stop push button with a seal-in circuit. So this is one that you want to get comfortable connecting. You'll see it over and over. So the way you'll do that is you'll come off the aux contact with a wire, go back to 3 or to 2. I like to stay on the start push button though, because it's branching around the start officially to do its job. So I think I would go into 3 with that. And off of this side, I would come back and go to 4. Okay. Now we have to be careful under that screw on the switch. Let's look at that start push button here. Oh, my light's going out. So I can have 2 wires under that screw number 3, and I'm going to have 2 wires here, one coming over, one coming back. So that's it. I can't put anything else there. I could come off of the screw on the auxiliary contact if I needed to. So I could come off of that and do something else. So I go to the starter. I have a green light just for show, so I know it's energized. If I press stop, I interrupt the current flow, everything turns off here. Okay, so here's your start-stop motor control circuit. M1, this is going to be known as a full voltage starter. Because when the coil is energized here, all 3 of the phases, if it's a 3-phase motor, all 3 phases of power will be connected to the motor and it will spin at full speed. It's a full voltage starter. So it's either on or it's off. It's not as good as a variable speed drive, but it's very simple and it works. It's fine if you're just turning a motor on and you're going to leave it on for a long time. It's not a good idea to use this if you're going to stop a motor a lot, because the inrush current from the starting of the motor will eventually cause it to overheat and trip the overloads. So this is also known as 3-wire control. 3-wire controls. Okay. It's for momentary start stops instead of a toggle or selector switch. This is really the preferred way to go, because if power fails, the starter turns off and it has to be restarted in order for it to operate correctly. Okay, so here's push button controls very briefly. If you look at a motor control center diagram, you'll see this exact diagram right here. Stop, start, motor starter, maybe a green light just for show, and a seal-in circuit coming back off the starter.